All right, in section 2.3, we're going to learn about how to name alkanes. Most of these rules are going to spill forward to every chapter once we start learning how to name all the other functional groups. This is kind of the starting point. So first we'll do the alkanes. We'll talk about the IUPAC way of naming. The IUPAC has very specific rules. And basically you just have to memorize all the rules and you'll be able to name every compound. There are also common names for a lot of compounds, like acetic acid is one. Technically it's called ethanoic acid. That's the IUPAC name. Acetic acid, though, is something that's been around for years. IUPAC, they've had a bunch of meetings all throughout the past 150 years. All the scientists from all around the world all get together and try to think of a common way of how to name things, because it got confusing 100 years ago or so when someone from America would publish a paper and they named it one way, and then someone from Japan would publish a paper and they had a different way of naming it, and someone from Germany or from France or Italy, every country or every scientist had a different way of how to name compounds. And that obviously got very confusing. So the whole world, all got together, all the chemists from all around the world got together, and all decided upon a way of how to name it where everybody names it all the same way. So if you're reading a paper from a different country, they name it the same way as how we would name it. Okay, and pretty much how it works is you have a prefix. Okay, these are the alkyl groups that we've talked about, or some other type of substituent. Other substituents might be alkyl halides, like you might have a chlorine or a bromine hanging off of your chain, or you might have an oxygen compound or a nitrogen compound, but we will talk about them as we go along. Followed by the parent compound. The parent is the longest continuous chain of carbons on your molecule. It might not necessarily be carbons in a straight row. They might actually hook around, but I'll show you examples of how that works. And then on the suffix, which is whatever family or group of compounds it comes from. So if they're either alkanes, it ends in ane. If they're alcohols, we'll learn they end in OL. If they're aldehydes, or if it's a ketone or a carboxylic acid, whatever family that compound is in is what the end of the name of the compound is. This chapter, however, we're just doing alkanes. So everything is going to end in ane, A-N-E. All right, the best way to go through the rules is by just doing examples. All right, so let's do a pretty simple one first. All right, you've already learned how to name the straight chain molecules, where they don't have any substituents hanging off of it. Okay? So this molecule obviously has a substituent hanging off of it. So what's the first thing you do? The first thing you do is you look for your longest continuous chain of carbons. Longest sorry about that. Longest continuous chain of carbons. Okay, and again, it might not be a straight chain. Okay, what you do is you just look for carbons hooked onto each other in a certain row. So, for example, obviously our longest continuous chain is right here. I've got one carbon here, 2, 3, 4, 5, 6. However, another way of counting this would be 1, 2, 3, 4. That is a continuous chain. Okay? Notice you have a carbon hooked to a carbon, hooked to a carbon, hooked to a carbon. It doesn't have to be in a straight line. That's very important that you understand that. And then a third possibility would be 1, 2, 3, 4, 5. So technically I have 3 continuous chains of carbons. I've got a 4 continuous chain, I got 5 carbon continuous chain, or I got the 6 carbon continuous chain. Obviously the 6 is the longest, so that is my parent compound. So since it's 6 carbons, it's a hex, which we learned previous section. And since the name, since this is an alkane, this is some sort of hexane. Okay? I now have to tell the reader that there is a CH3 hanging off of it. Okay? So that comes now in part 2. Part 2 is you have to number the chain. Number the longest chain. Okay? So there's rules. The rule is you start at the end closest to the nearest substituent. I know that's a lot of words there. So start at the end closest to the nearest substituent. All right, you might have more than one. In this case, we only have one. So again, it's very simple, but I want to do some easy ones first, and then we'll get a little bit more challenging. So you technically can number in 2 ways. Okay, I can either number this way: 1, 2, 3, 4, 5, 6, or I can number 1, 2, 3, 4, 5, 6. Okay? Well, which way is correct? Well, it's this way. This is the correct way because my nearest substituent is this group right here, is the CH3 group. Well, if I start at this end right here, it's 1, 2, 3, opposed to 1, 2, 3, 4. So since 3 is a lower number, that's your substituent is closest to the nearest substituent. That's the side I start on. Okay? It's not always I start on the left side. Okay? I can start either side. It just all depends on where the first or the closest substituent is. Like I said, I could have a second substituent on there that might be closer on the other end, so that's the end I would start. Again, I'll show you examples. So, this is a substituent. This is an alkyl group. So the name of this group, of the CH3 group, is methyl, like we've learned in 2.2. All right? If it was a CH4 group, it's methane, but since it's an alkyl group, it's hanging off of my chain, it's called a methyl group. So, and then the way that you name this is you put the number of where the substituents are first, so our prefix first. The prefix is where all of the substituents are and what carbons they're on. And you do that alphabetically. I'll show you examples later. The parent, which in this case is hex, and the suffix is ane. So the name of this would be 3-methyl-hexane. Okay? You always put a hyphen between numbers and letters. Okay? You could put a space here. You don't have to put a space there. I see it done all sorts of ways. I'm not really going to be that strict on it. You can do whichever one you want, as long as you understand these straightforward rules. Okay? Let's do another one. It's going to be a little different this time. I want to show you an example of where your longest continuous chain is not necessarily straight across. Okay? Because this is important. You have to understand this, otherwise you might get the wrong longest chain. Okay? So if you just go straight across, you've got 1, 2, 3, 4, 5, 6. That's the longest continuous chain. Another one would be 1, 2, 3, 4, 5, 6. That's 6. And then another one would be 1, 2, 3, 4, 5, 6, 7. Okay? That is a continuous chain. It's a carbon attached to a carbon, 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 attached to a carbon. There are no breaks. Okay? If you have to jump over a carbon, that technically is not a continuous carbon at that point. Okay? So that is what's meant by a longest continuous chain. So this would be my longest continuous chain. Okay? And this would be the substituent. So numbering, remember, you number from the side closest to the nearest substituent. In this case, it's equal. I either have 1, 2, 3, 4, or 1, 2, 3, 4. So it doesn't matter what side you count on because it's always going to be 4. Your substituent is always carbon 4. Okay? So, since this is a 2-carbon fragment, this is called a ethyl group. Okay? And since we have, what did I say, 7 carbons here? 1, 2, 3, 4, 5, 6, 7. That is a heptane. So the name of this, why don't you put this on pause and you can practice the name. I'll give you a second. The name of this would be 4-ethyl heptane. Okay? Let's do another one. CH3, CH2, CH, CH2, CH, CH3, CH3, CH2, CH2, CH3. Made it look a little crazy here, right? Obviously I'm doing this on purpose. Why don't you put this on pause and look for the longest continuous chain? Alright, you should have gotten 7 carbons. Okay, 7-carbon chain. Now what I want you to do, I'm going to put it on pause again. I want you to number the chain. Alright, number it in the correct order. Start on the correct side. I'm going to put it on pause, number it, and then when I come back, I'll have it already numbered for you. Alright, so I have the longest chain outlined and I have it numbered. Notice this carbon right here is carbon 1 in this case. This carbon right here is carbon 2. Here's carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. Okay? Why did I start over here? Because I have a substituent here, that's a methyl group, and I have a substituent here, that's an ethyl group. Well, remember, you start at the end closest to the nearest substituent. This end, I get to my first substituent on carbon 2. If I start counting on this end, 1, 2, 3, 4, I get to my closest substituent on carbon 4. So that's why I start on this end. It's very important that you start there. Okay? So, notice I have an ethyl substituent and I have a methyl substituent. This time I have 2 substituents. So the question is, how do I name this? Do I name the methyl first? Do I name the ethyl first? Okay? What the rule is, and it is a weird rule. I don't necessarily think it makes sense. I think well, I'll just tell you the rule. The rule is that you name this alphabetically. Alphabetical order. Okay? Ethyl obviously comes before methyl in the alphabet. So this would be called, I'll tell you what, I'm going to put this on pause. I want you to write out the name, and then when you come back, we'll see if it matches. Right? So there's the name. 4-ethyl 2-methyl heptane. Okay? The ethyl group alphabetically comes before the methyl. What would make sense to me, but it's not what it is that you would just name it all based on numbering and just put the 2-methyl first. But there are reasons why you do it alphabetically. For other molecules, it makes a lot more sense. So that's just what it is. That's the rule. You just have to know how to do it. Okay? Let's now do another. I'm going to do a few of these problems so that you get an idea of all of the what-if scenarios. I can't go over every single possibility. You can read more in your book. You'll have a lot more in practice. But for right now, let's get through some of the most common ways of naming it. So I'm going to put this on pause. I'm going to draw out the molecule so we can save some time. Okay, here we go. Here's a molecule. There's a lot of crazy stuff going on here. Look for the longest continuous chain. All right, see if you can figure out what the longest continuous chain is. I'll give you again, put it on pause. All right, the longest continuous chain is right here. There are 2 possibilities. Doesn't matter which one you choose, you'll get the same answer. But that is the longest continuous chain. Okay.